Alright, today we're going to continue learning about coordinate geometry, and we're going to learn about distance or length between 2 points. Now let's recall something that you've learned previously. When we are given a right angle triangle, we can actually use Pythagoras theorem to find a missing length. So in this case, you can see that Pythagoras theorem, right, is actually a squared plus b squared equals to c squared, where a and b are usually the sides that are just next to 90 degrees, and C will be the hypotenuse. I have also a second triangle with values where you can actually try to see how the working is. Like for instance, if A is 3 and the B is 4, we can replace it in. 3 squared plus 4 squared will give us 9 plus 16, and that will add up to 25. But that is for C squared. To find C, we have to take the square root of 25, and therefore our value of C is 5. This 5 means that the hypotenuse length is actually 5 units. So let's revise. Find the value of x and of y. You see the two diagrams. Pause the video, try it out before you check the answers. When you're ready, press the play button. So, do you get the answers correct? So for the first one, your x value is supposed to be 10, and for the second one, your y value is supposed to be 5. Now let's move on. When we want to find the length of a line segment or the distance between 2 points, we can actually draw a triangle and then find how many units there are for the rise and run, because this will give us the A and B values for Pythagoras theorem to work. So in this diagram, we can see that the rise is actually 6 units, the run is 2 units. So using Pythagoras theorem, we will replace A as 6 and B as 2. 6 squared will give us 36, 2 squared will give us 4. Adding that up, we get 40. So to find C, we will take square root of 40, and that will give us 6.32, correct to 3SF. So this 6.32 is actually the length of the red segment. So now you try. I have given you 2 coordinates, and I've also helped you with the triangle. Find the length of the blue segment. Again, pause the video, try it out, and once you are ready to check your answers, press the play button. So here are the answers. We have 3 units for the vertical rise and 7 units for the horizontal run. Putting them into Pythagoras theorem, we have A, which is the rise, 3 units, B, the run, which is 7. So similarly, we will add them up, then we will get 58. So C is square root of 58, which will give us 7.62 units, correct to 3SF. So in other words, the length of the blue segment is 7.62 units. Or we can also say the distance between the 2 coordinates is 7.62 units. Let's try another one. Find the distance between the points 0, 3 and 4, 1. So you can see the 2 coordinates being plotted out. So I want to find the distance between the 2. To make it easier, we will connect them with the line segment that is in red. And we will also try and form a triangle. This will give us a clearer picture of how many units for the rise and how many units for the run. Rise is 2 units, the run is 4 units. So putting them into the Pythagoras theorem, we have 2 squared plus 4 squared is equals to C squared. And then we are going to be able to get C as square root 20. And this is 4.47 units, correct to 3SF. So in other words, the distance between the 2 coordinates is 4.47 units. It is also known as the length of the red segment. Now you try. Find the distance between -4, 6 and 5, 3. Pause the video, try it out, and when you're ready, press the play button to check your answers. So let's check your answers now. As you can see, I've already plotted out the point, -4, 6 in red and 5, 3 in blue. Connect them with the line segment. Again, we try and form a triangle. Rise is 3 units, run is 9 units, and we are going to put it into the Pythagoras theorem. Putting the values in, we add them up. To find C, we'll take the square root of 9 plus 81, which is 90, and we'll be able to get it as 9.49 units. So again, remember, this is the distance between the two coordinates, or is also known as the length of the red segment that was connecting the two coordinates. Now, what if you do not want to really draw it out all the time? Is there another method? You can actually just go by finding the difference between the y values and the difference between the x values. If you remember, when we did gradient, that is actually the rise and the run. So what we can do is that we can actually use this formula, which is actually the same, a squared plus b squared, and then you take the square root. So now we will just say difference in y and difference in x. Using the coordinate on the right, the y value is actually 1. We find the difference with the coordinate that is on the left, the y value is 4. So the difference is 1 minus 4. Now, for the x value, we again start with the same coordinate that's on the right. The value is 5. And we take the difference with the x value of the other coordinate on the left, which is negative 2. So what we're going to get is, we will have negative 3 squared actually will be the same as 3 squared, because the negatives, when you square anything up, it doesn't quite matter. So we will be able to get it as 58, and then you will be able to get it as 7.62 units. So you can actually just use by calculation. You don't have to draw it out, but I personally think by drawing it out, it will make it a lot easier. So similarly, when I actually taught you about the gradient, we also keep the order the same. If we start by using the coordinate on the right as the starting values, we have to keep it all the time. The right value, the right coordinate will be the one that we start off with. We're going to get you to try one more question. Find the distance between 6, 4 and 3, 2. So there are two coordinates here, right? So you're supposed to find a distance. You can use any method that you like. So pause the video, try it out, and once you're done, press the play button to check your answers. So here it is. I'm showing you both methods. The first method is by drawing out. By plotting the point 3, 2 and 6, 4, you can actually see that you have the red line segment, and you can also draw the triangle to give you the rise of 2 and the run of 3. Putting it inside, you'll be able to get it as 3.61. Second method, you're just using by the difference in the y. So you can see y value for the coordinate on the right is 4. Y value for the coordinate on the left is 2. You find the difference. Then we do the same for the x. X value for the coordinate on the right is 6. X value for the coordinate on the left is 3. So you find the difference, which is 3. So you also will be able to get the answer as 3.61.